Big welcome to everyone to DevCamp 8 session 3. We've got, I think, a pretty interesting session lined up. We have pre-break. Nastasia is going to make a presentation on the mega architecture scheme, which is an overview of how things play together. And then we have a DNA/Zoom structure session by Nastasia again. That should take us to halfway, and we'll do a little break. Or if we have time before the break, depending on how much time we have, we'll do Q&A before the break. After the break, we're going to have a scaffolding demo by Nastasia and 8C, a holochain tooling overview by Guillem, and then Q&A again. And yeah, looks like an interesting session. For those who are watching this recording, questions are being shared in the Discord group. So even if you haven't joined, you can follow some of the questions and subsequent conversations in Discord and the holochain forum. So yeah, we look forward to more conversations spilling out outside of this Zoom chat. So with that, handing it over to Nastasia.
Yeah, 1 second. I will share my screen. All right, can you see my screen now?
Yep, all good.
Okay, so I know that we have already done the architecture overview last week, but hearing a lot of questions and getting some feedback, I realized that there are a bit more details to cover. So today we would recap things that we have learned about the architecture and then use them as a foundation to talk about the scaffolding of the project, and we would start to actually get to the code. So first is, I don't want to show the entire scheme in a single moment in time, so I would start small. So imagine we have 4 users, Alice, Chris, Bob, and Diane. They all have different setups. So for example, Alice and Chris are sharing the same computer, which only executes a single holochain conductor. And then Bob has a computer to his own, so he's the only user who is running anything in there. And then Diane actually doesn't have a computer, she only has a tablet or a phone, so something mobile. So when we speak about communication that's happening here, there are multiple levels. Last week on Tuesday, I have talked about the holochain conductor having taken care of networking and executing all of the applications inside the WASM sandbox. But I didn't get into the specifics of what's exactly in the sandbox and how this all is working. So every instance of the application, which in our case is identified by DNA called DNA number 1, so basically any kind of application, would be executed in a cell. And as some attentive people on Discord have pointed out, I didn't include cell into my slides about Rust structure, and it wasn't anywhere between the DNA and Zoom, and so it wasn't anywhere. That's because cell is a runtime concept, which is used to instantiate a certain DNA for a certain agent. So, for example, in this example here, it allows 2 different agents to execute their instances of application while only using the single holochain conductor. That's because every cell includes the agent key of the agent to which it belongs, and then it stores all of the data for application inside of it. And you can see that as a higher level of abstraction, in every cell, we are storing a DHT shard which belongs to this agent, and then together these DHT shards from here are combined into an abstraction of an entire DHT. So that DHT isn't stored in some external place. It's stored as single chunks, as multiple separate chunks here, 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 and here. But then from the purposes of application and going into the next sessions of the DevCamp, we would be always picturing it like that just because it's easier to reason about. So on a conductor, we have the WASM executor, which is executing the Rust code, which is compiled into WebAssembly. It sandboxes every application. It stores source chain of an agent locally without propagating it anywhere. And then the DHT shard, which corresponds to the application that's running, is propagated between the nodes. The networking module of a holochain conductor is responsible for networking between the applications, which I didn't picture here, and also for the networking between the different conductors. So here you can see that in order to discover any other conductor on the network, this network module would send the discovery traffic to a bootstrap service, which is known beforehand to this conductor. So maybe you have a set of bootstrap services for your application, which users would know, would get with the bundle of your application. So the discovery traffic would reach the bootstrap service, which by that time either already knows about other nodes or would just store this node as being registered running DNA1 application. So the bootstrap service allows to establish connections between another conductor, which is sitting behind the proxy with the public API, because, for example, this conductor doesn't have a public IP of its own. And then another instance of application is running in the whole network, which is pictured here as a cloud because there are actually a lot of moving details inside of the whole network, but we wouldn't be talking about them at all. I mean, that's an infrastructure subject. There are a lot of things to discuss, and we just want to make sure we can build a simple, basic whole chain application. So as you can see, the discovery traffic always goes through the bootstrap service. But once every conductor knows about existence of the others, the actual application traffic only goes between the conductors themselves. But since this conductor is behind the proxy, all of the traffic would be going through the proxy as well. Proxy wouldn't be able to decipher the traffic that's going through it, but it would be a necessary part of the network infrastructure. And then, so everything else we would be doing during the DevCamp would be focused on this green part here. So a higher level of abstraction on top of everything that's happening here. And yeah, I think that's it. And then just to quickly continue this idea. So 1DHT. 1DHT corresponds to a single DNA that's being executed by multiple agents. And we would have a lot of, usually the question of whether or not to create a DNA or a zone is a very common one. So I want to try to answer it beforehand. So you have a DNA. DNA is something that multiple agents can execute. So that's an application on itself. Every DNA would correspond to a separate DHT, meaning that every network of agents which are executing the same code would have its own data storage inside of this network, which is only available to those running the same code. So, and then zone is actually a building block of a single DNA. So every time you think whether or not should you create a separate DNA or just create a zone, think about, do you need a separate data storage for the code that you're about to write? Or would it have to have an access to something shared? So for example, we would be doing a game during this DevCamp, and I tried to picture this DNA here. So we have a DNA for the game. And inside of this DNA, we could have multiple zones. One of them would be executing the actual game logic and nothing else. Another one could be handling the user invites so that users can interact between each other inside of this same DHT and send each other invites for some games that they're playing. And then also to store in the same DHT, we could have a profile zone, which would be implementing user profiles that they would be creating in this shared data storage. But then, for example, and that's a made up thing which we wouldn't be doing during the DevCamp, let's say we want to have a marketplace for our games. And then the marketplace would be something optional. So a user may choose to participate in it or may choose to not participate in it. And then in my example, you can see that only Diane, Chris, and Bob decided, I got confused by my pictures. So yeah, all 4 users are participating in this DNA, but only 3 users are participating in this one. So that's a perfectly valid example, and you could do that. So if you wanted to make something separate, logically separate, with its own data storage, with its own set of users, then you would create a separate DNA. But for the purposes of this DevCamp, we would only be working with a single one. I just wanted to add it here for your overall architecture questions.
We will now have a scaffolding demo by Nastasia and a holochain tooling overview by Guillem. Nastasia, are you going first?
Yeah.
Yep. So we'll have Nastasia with scaffolding demo, and then holochain tooling overview by Guillem, and then we'll have some Q&A.
Thank you. So I would be doing a demo of the scaffolding tool, which we would use to create our project, in which we would be doing any further development during the DevCamp. We didn't update our environment configuration yet, but the thing is that to use the newest scaffolding tool, which just has been recently released, you would need a Node.js setup running on your machine. There are 2 options for you available. You can either download the Node.js binaries directly and have them on your machine, as I did. So the npx binary is available on my host Ubuntu OS. Or you could run the same Node thing from the Nix shell from any holochain project if you already have them available, because Node environment comes bundled in with the holochain dependencies in Nix shell for every project. But if you do not have anything available, just get your Node binaries, and then your entire scaffolding process starts with this sample command. So that's a command that would execute the package for scaffolding, and I would walk you through the process step by step. So as I am executing this package, it would show you a pretty cool ASCII art by Guillem, and then say to you that app is running at localhost on 3000 port. So that's a small bug in my Ubuntu. Do not mind that. So that's the application that's running right now in my browser, being served from this process in the command line. And here you can see that I am prompted to enter data about my new application, and I can enter the name of application. So I will leave my app just to avoid typing too much. So you would be typing name of your application, you would be typing name of your DNA, which could be different because a single DNA could be used in multiple applications. So these 2 do not necessarily match directly. And then you can configure how many zones would be in your application. As I have mentioned before, we would only be creating a single zone for now, so there is no need for me to change it. But if I wanted to create multiple zones, I could do that like that. So I would provide the name, a separate name for each one, and I have deleted the one that I didn't need. Here you can also choose the UI template that would be generated for your application based on the on the web framework that's used to create it. And there are multiple options available. During the DevCamp, we would be using the Svelte framework, so I'm going with this option. And just to get you started and to get you any help you need, check out these links here, which are super useful and would help you to get context on what's happening. Once you are ready to, once you've decided that you filled in all of the details necessary, you can click the Scaffold app, which would prompt you with a note saying what kind of directory structure would be created in the directory from which I executed this command. And that looks fine to me, so I'm clicking the create. Now there are 2 things that could happen here. So we need to set up the environment for the application directory structure which I have just created. And I can either do this manually by executing those commands, or I could just click this setup and exit, and then this whole thing would be executed automatically. And I'm choosing the second option. So now this window is no longer needed. And as I switch into my command line, you can see that when I started running this scaffolding, there was only that text shown. So anything below that appeared after I have clicked setup and close. So you can see that it's running all the same commands to set up the Nix shell with the CacheX client. CacheX client is a cool thing which really reduces your compilation time. And depending on the hardware that you are running, it could be a different value, because for Guillem, it's reducing the compilation time to a matter of minutes, but my laptop is not as powerful as his desktop. So for me, it's about 15 minutes instead of 2 hours. So still a significant change, but not the numbers are not the same. So here you can see that it's going to be installing a bunch of dependencies and downloading a bunch of things. And while this is happening, that's just the thing that you have to wait for. And there is nothing you need to do in between those steps. And once it downloads, we would have an actual directory structure with the populated environment. And just to show you what's happening in the directory which I have just created. So I've been running this in the session3 directory, and you can see that there is already my app available. And while dependencies are being installed, I can start the Visual Studio Code from this directory and show you what's happening here. Also, for anyone interested, VS Code is not actually the command available to anyone. That's an alias that I have defined for myself, because it's easier for me to add the scale factor so that interface is easier to work with. So anytime you see the VS Code, that's actually that command being executed under the hood. So let's see what has been created. So first of all, we have the README, which contains all the instructions for this dummy scaffolded application. And then we have the package JSON, which defines scripts available for this project on the level of node. And this is a very useful file for you to look at, because you can see what kind of actions are available for you to run inside of this repository. So these could only be run in the development environment, which is downloading for me. So I cannot show you right now how it executes. But you can see that we have commands to run the actual application, execute the integration tests, which I would cover in a minute. We can package the application, an entire application for the whole chain launcher, which we showed last week. And we can also package the UI separately. There are some other things in this file as well, but this is the most important one. And honestly, I'm not very much aware of the rest of the details here. So let's go to the next one. This file here is the core piece of the Nix shell setup, in a sense that because it's located in this repository, this is where all of your environment configuration comes from. So you don't have to touch it. You just have to know that executing the command Nix shell has to happen from the directory with this file, because that's where the build configs are. Now, cargo.toml. No worries. So that's the highest level Rust configuration manager file, which defines that we have a workspace. That's a Rust thing for managing multiple projects with a single runtime configuration. So we have a workspace inside of which we only have a single member, and that's where all of the code to be built is located. But on the level of workspace, we are also able to configure some compilation options, as in optimization levels. And for now, that's it. So there is not much to see here, only that the location of your backend code is in here. So, the git ignore, make sure that we do not commit anything unusual in the git. The work dir is a directory in which your application configuration is contained, and you wouldn't need to modify these files manually. They are generated for you, and they just explain what kind of application you're running, how many DNAs are in this application. In this case, you can see that we only have one item called my DNA, the one that I have created, and then some properties of the DNAs. You can skip this for now. We would be talking about them more as we go deeper into the DevCamp and add more features. Then the user interface is located in the UI folder, and that's essentially a Svelte project which has its own package.json, which allows to control what can be done about this project. Then the test directory on the upper level contains the integration tests for the backend. And these are the integration tests that are very specific to Holochain in the sense that they create an emulation of multiple conductors in the network. So you can test how your data propagation works, how different agents in your application are able to interact with the data. You can check if some data being created is indeed private or public, and more other things that we would be doing during the DevCamp. And here for the tests, you can see that we already have the source directory with an index file, which is a very small one. It just defines the setup for the tests to be executed. And then the actual DNA tests for my DNA are located in this folder. You can see that the test file created matches the name of the zone. And I would get back to the contents of these tests after we review what's created on the backend. So node modules is a directory for dependencies. You don't have to go there. It just contains everything needed for node to execute properly. And last but not least, the DNA directory, which is where all of your backend would be located. Here you would have the DNA configuration, and there you would have a directory for every zone that's included in your application and its Rust source code. In our case, we only have a single zone, so we have the Rust project definition here. As you can see, it has the package instead of the workspace, meaning that this is an actual Rust package to be compiled. We have some basic Rust configuration, which I wouldn't be going into. And then we have the source code for the zone that's been generated. Since it's an example scaffolding application, this is all of the source code that we get, and it's very, very minimal. We are defining a single Holochain entry called post, which would only contain a single unnamed field of the data type string, meaning that we're able to create some arbitrary strings inside of our basic Holochain application. Then we have a block where we are using a Holochain provided macro, which you can note by this exclamation point, where we provide the entry definitions that are available in our file. In this case, you see that we are executing post entry def. And the question you may be asking yourself is, where is the definition of entry def which we're using? We didn't write it anywhere. That's where the magic of macros comes in. The thing is, when you apply that kind of macro to this code, it actually means that during the compilation, Rust compiler would generate additional code using the rules defined in this HDK entry macro. And one of the things that would be auto-generated for us would be a function called entry_def, which is a boilerplate code which defines for Holochain how this entry with a single string type, field should be treated. So after we have actual entry definitions, that's basically our data model. We now are defining our API for the zone. So what are the functions that would be exposed to the user interface to call, and what would be happening inside of those functions? Every such function, which is publicly exposed to the user interface, has to have this macro HDK extern applied to it. Otherwise, the boilerplate code that makes this function available wouldn't be generated, and it would be just one of the private functions which are only available inside of your Rust package. So I wouldn't be going detail by detail here, but essentially we're creating an entry of type post, and we're returning its hash. And then we also have a second function which retrieves some entry with a provided hash. And then if the result has been successful, if this entry actually exists, we are returning contents of this entry. So that's the backend code. And do I need to pause for any intermediate questions? I'm not finished with the demo, but if there is anything urgent, we can cover it right now.
No, keep going.
Okay, good.
But just a quick note, if people do have questions coming up, just drop it in Discord. Thank you.
Yeah, thank you. So we are only able to create an entry and then retrieve the entry. So let's see what kind of tests we have generated for that kind of logic. Going back to
You will be dearly missed.
It happened also last time. Let's give a few seconds and Nastasia is gonna come back again. Yes.
I'm sorry.
Yeah, this is okay. Go ahead.
Yeah, ever since the elections, my internet is really weird. I'm sorry about that. I didn't want to put it through the VPN. All right.
Just a quick message from Thomas. He says the code is cut off the right side of the screen.
Oh, right. 1 second.
This is better.
I can do like that. Okay, so that one will move here. All right, is it better now?
I don't know. Yes, Thomas says yes.
Okay, awesome. So the integration tests. In these integration tests, we are assuming that we would be testing a setup where we have 2 players, Alice and Bob, and they would be executing our application. So this is the setup code that's necessary for getting the test running, and we would have a separate session dedicated to tests. But until then, just consider this as something that you just have to leave there and not worry about the details of how it works, unless you really want to, of course. So in this test, we are specifying that we would try to create an entry called myPost, meaning that the string value that we are trying to put into the DHT would be actually myPost. And then player called Alice calls the function createPost here, specifying that this function is to be called from the zone called myZone. And then the value that's provided for this function is actually the post contents, which we created here. Then we sleep for a few milliseconds, which is a necessary measure to make sure that data propagation has enough time to happen, because it is a decentralized network and nothing would happen instantly. And then after we do this wait, we make sure that Bob, second agent running the same application, is actually able to use the post hash value that Alice has received to retrieve the same post that she has created. And then we verify that the post retrieved from the DHT by Bob and the post created by Alice actually have the same contents. Now, let me check how my download is going. It's finished. So that's how it looked. It has been downloading a bunch of stuff here. And then it has printed, in the end, commands that I should follow in order to set up my environment. That would also be something that you would see. So I'm getting into my directory, and I'm running the Nick shell. So that's the setup that could take some time. Once again, could be just a few minutes. Yeah, I'm getting lucky today. It's just been a few seconds for me right now. So I am now in the Nick shell environment that's configured for this specific project using the holochain version and all other dependencies that are required to compile this code. Now let me actually build the application that we have just created. That process could take some time. Once again, it would be building the Rust backend, and it would also have to download dependencies of the packages from the crates.io, which is like Rust registry of packages. All right, in the meantime, my application has been built. Let me remind myself what I had to run after that. So we've run so far those commands, and now we only have to run the Npm Start. Let's see how it goes. So it has packaged the entire application, as you can see here. So this is the file. These are the files in which the backend and the user interface are stored. And now, so all of these logs are normal. Please do not be scared by these 2 lines here. These are absolutely okay. So just don't worry about them. And the same applies to, the same applies to these ones. it looks suspicious, but Guillem told me that it's absolutely okay. So now you can see that my application is being served on localhost 8000, and let's see what's there. So that's our application, which is actually doing a very simple thing. So it's showing the hello world, and then it's creating an entry in holochain of the type post, and then it's printing us the hash of this entry that we have created. So it all worked perfectly well. Now, to add another cherry on top of that, I can package the same application into the package for holochain launcher and then run it through the launcher instead of serving it directly from my repository. Guillem, could you remind me the command to package the application? I forgot.
npm run package.
Cool, thank you. So now we are creating a package file, which is the similar one to what we've been using with the elemental chat and chess last week. And that will take a while. In the meantime, I would run the launcher in a separate shell. Right, yeah, so it's zipped, and you can see the path to this application here. Now, this is my launcher. And now I would install this. Okay. Yeah, sorry, put it way back. So that's here. I do not have to provide any other information as in UID because there is no code to process this information. So it's pretty much useless. And now I'm installing this application and running it through the launcher. So that's now is taken care of by this user interface. I don't have to run my whole chain conductor. And you can see we have started the same application and it did its thing. So that's basically it for the scaffolding demo as a homework. We want you to copy these steps that I have shown just to make sure that you're able to create a project on your own. And if you have any problems, please let us know on Discord or on the forum. And then also, let me check the tests. I didn't run the tests yet. So npm run test. So try to create a project using the scaffolding tool and then compile the application, package it, install it via the holochain launcher, just see if it's working. And then you can also try to execute the integration tests. Once again, just to get the sense that it's all happening. And if you want, you can also break some integration tests and alter some code. So just feel free to play with this thing. And that would be the foundation for you to do any other development that we would be continuing on the next session. So right now you can see that tests are producing some limited debug output. And as a summary, we see that we've had 2 tests and both of them have passed. And to cross-reference it with the code here, you can see, so that was the test number 1, where we have verified that the post hash value that we have received is actually a normal value, meaning that operation executed successfully. And then the second test was to verify that these 2 things are equal. And I see that we are running short on time, so I would stop sharing and pass the cue to Guillem to talk about HT tooling.
Yeah.
Can I say something before continue? So the scaffolding just is giving you the whole possibility for you to build. It is a new tool. Previously, in the holochain in action, we also have 2 other options if you would like to see everything is in detail. In one video, we created an application totally from the scratch. It means from the Rust, create cargo, blah, blah, blah. And in another video, Guillem in a geolocation, create a project based on the templating. I'm gonna paste both of them in Discord. Up to you. If you would like to see everything in detail, go to the from the scratch. If you would like to rely on the scaffolding, go to the tool that you saw. If you are fascinated to detail behind the scene, right now you have all possibilities and options. Thank you, Guillem, please.
Elemental Chess because it's a project that I know very well. Right, so I'm inside the Elemental Chess project, and here it's a very similar setup than the one that we have following the scaffolding tool, right? So you have the word, dir setup, DNA, and so on. So if I go inside the Nix shell, oh, okay, yes, that's okay, cool. I was about to. Yeah, okay, so hopefully I have the Nix shell. Fortunately, I have the Nix shell cached. So the thing is that there are multiple levels of packaging that are included in Holochain, answering your question, Moritz. So each of these YAML things, it's a manifest in which you declare your dependencies. Like, for example, to package a DNA, you have to say the name of the DNA and which zones it contains, right? To package a hub, you have to declare the name of the hub and the slots that the DNA slots that that hub includes, right? And then a web hub is just the .hub and the UI bundled, right? So that's a bit of the internals. You don't have to care too much about this right now, but if you go a bit further with scaffolding and start adding zone and start changing directories, you will have to date these manifest files in order for you to be able to keep the application working. Right, so for example, here we have the hub.yaml, and there is a very, very handy tool here inside the Nix shell, inside any Holochain Nix shell, which is called HC, right? So if I do HC, this is the Holochain CLI, right? And if you see, we have different subcommands. Okay, I'm going to do this very, very quickly, just an overview of what can be done with this tool. But the idea is for you to play a bit with it, go inside the help of each of the subcommands and see what you can do with it. So, for example, if I want to package what's inside the hub.yaml, I just need to do HC app, and then HC app displays help, and then we have HC app pack, and then the name of the directory in which hub.yaml is stored. So in this case, it's work there. Okay, and this actually packages the application into its own .hub, right? This is not yet launcher compatible because we need the UI in that as well. But luckily, we have the web hub.yaml here as well, and the command in this case is hc web app pack work there, right? So this is doing the exact same thing, one level up. This is getting both the .hub, which we have just created, and the UI zip, and this is already launcher compatible, right? You have this is what these commands are doing under the hood. If you go inside and you see what's build hub doing, it's HC app pack this, HC DNA pack that, right? So the scaffolding tool provides you everything you need, but if you want to go a bit deeper, it's really useful to see what it's doing under the hood. And the last thing I want to cover is the Sandbox tool, right? So the Sandbox tool, it's a very useful, very, very useful thing for you to know, which is basically a way for generating, running, and interacting with Holochain conductors, right? So just for example, I can do something like HC Sandbox generate, and the path to my .hub, so in this case is elemental chess.hub, and I can provide -r, which is run it already with a port, and this will create a new conductor, install this application in it, and have the and those are the logs. You won't be seeing that. Don't worry. And listen to the port 9999, right? So with Sandbox, what you are able to do is play with creating conductor, installing applications, managing everything, so that it's easy to you for you to have a good developer environment and do testing and do UI, I don't know, whatever you want to be doing in your application. And this was very, very brief because we are running out of time, but I hope it just gives you an indication that you can go further and look at the help in HC Sandbox and everything else so that you can begin to feel comfortable with a Holochain developer environment. This is it.
I also wanted to add a short note that the integration test would be emulating a situation where you could have multiple conductors running on your device, but the sandbox is what actually allows you to play with those conductors yourself. So if you want to manually emulate some kind of setup with 3, 4 more nodes on your machine, and then see how would they be executing and play the user interfaces for all of those nodes, you would be using Sandbox.
Thank you.
Bye.
Goodbye.